Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. This problem involves an acid-catalyzed polyene cyclization, biomimetic cationic olefin cascade cyclization, similar to the biosynthesis of steroids from squalene oxide. Moving on to the next step. The starting material is a polyene alcohol, resembling a monocyclic terpenoid with an allylic alcohol on a cyclohexene ring, bearing a geranyl farnesyl-type side chain with multiple trisubstituted double bonds. This is structurally analogous to a biosynthetic steroid precursor. Moving on to the next step. Under H3O+ conditions, the tertiary allylic alcohol is protonated and the hydroxyl leaves, or the OH, acts as initiator of a cationic cascade. The resulting carbocation triggers a concerted or stepwise cascade cyclization of the polyene chain. Each alkene in the chain attacks the adjacent carbocation in a Markovnikov sense, forming new C-to-C bonds and new rings sequentially. And for the final step, the cascade builds a tetracyclic framework, 3 6-membered rings, A, B, C rings, and 1 5-membered ring, D ring, exactly like the steroid carbon skeleton. The terminal alkene, isopropylidene end of the geranyl chain, ends up as a tertiary carbocation that is captured by water to give a tertiary alcohol, C, CH3, to O. The product is a tetracyclic compound with an ABCD ring system, steroid skeleton, retaining one double bond in the A ring, the original cyclohexene double bond that initiated or participated in the cyclization, with angular methyl groups at the BC and CD ring junctions and A, C, CH3, 2-OH group on the D ring, cyclopentane. This matches option A exactly. Option B shows no double bond in the A ring. The original cyclohexene double bond should be retained in the product since it is not involved in the cyclization cascade. The OH departs and cyclization proceeds through the side chain alkenes, so the A ring double bond persists, ruling out B. Option C is a fully aromatic polycyclic hydrocarbon, which cannot result from this type of acid-catalyzed polyene cyclization of an aliphatic substrate, ruling out C. Option D is eliminated since option A correctly describes the product. Therefore, the correct answer is A. Therefore, the correct answer is option A.